Welcome to Flourish. I'm Diane Planidin, and you're in the right place if you're ready to create an inspired life. And we do so by working on our own personal development, so we can be strong role models for those we love and mentor. Today is Chapter 6 on Research Designs at Psych-100 Queen's University course. So let's get started. Psychologists test research questions using a variety of methods. Most research relies on either correlations or experiments. With correlations, researchers measure variables as they naturally occur in people and compute the degree to which two variables go together. With experiments, researchers actively make changes in one variable and watch for changes in other variable. Experiments allow researchers to make causal inferences. Other types of methods include longitudinal and quasi-experimental designs. Many factors, including practical constraints, determine the type of methods researchers use. Often researchers survey people, even though it would be better, but more expensive and time-consuming, to track them longitudinally. The learning objectives for this chapter, and I am not a teacher, I am a student, but this is what I keep in the back of my mind as I study the material, is articulate the difference between correlation and experimental designs. Understand how to interpret correlations. Understand how experiments help us to infer causality. Understand how surveys relate to correlation and experimental research. Explain what a longitudinal study is. List a strength and weakness of different research designs. Research designs. In the early 70s, a man named Uri Geller tricked the world. He convinced hundreds of thousands of people that he could bend spoons in slow watches using only the power of his mind. In fact, if you were in the audience, you would have likely believed he had psychic powers. Everything looked authentic. This man had to have paranormal abilities. So why have you probably never heard of him before? Because when Uri was asked to perform his miracles in line with scientific experimentation, he was no longer able to do them. That is, even though it seemed like he was doing the impossible, when he was tested by science, he proved to be nothing more than a clever magician. When we look at a dinosaur bones, we make educated guesses about extinct life or systematically chart the heavens to learn about the relationships between stars and planets or study magicians to find out how they perform their tricks. We are forming observations, the foundation of science. Although we are all familiar with the saying, seeing is believing, conducting science is more than just what your eyes perceive. Science is a result of systematic and intentional study of the natural world, and psychology is no different. In the movie Jerry Maguire, Cuba Gooding Jr. became famous for using the phrase, "Show me the money." In psychology, as in all sciences, we might say, "Show me the data." One of the important steps in scientific inquiry is to test our research questions, otherwise known as hypotheses. However, there are many ways to test hypotheses in psychological research. Which method you choose will depend on the type of question you are asking, as well as what resources are available to you. All methods have limitations, which is why the best research uses a variety of methods. Most psychological research can be divided into two types: experimental and correlational research. Experimental research. If somebody gave you $20 that absolutely had to be spent today, how would you choose to spend it? Would you spend it on an item you've been eyeing for weeks, or would you donate the money to charity? Which option do you think would bring you the most happiness? If you're like most people, you'd choose to spend the money on yourself. Duh, right? Our intuition is that we'd be happier if we spent the money on ourselves. Knowing that our intuition can sometimes be wrong, Professor Elizabeth Dunn at University of British Columbia set out to conduct an experiment on spending and happiness. She gave each of the participants in her experiment $20 and then told them they had to spend the money by the end of the day. Some of the participants were told they must spend the money on themselves, and some were told they must spend the money on others, either charity or a gift for someone. At the end of the day, she measured participants' levels of happiness using a self-report questionnaire. But wait, How do you measure something like happiness when you can't really see it? Psychologists measure many abstract concepts, such as happiness and intelligence, by beginning with operational definitions of the concepts. In an experiment, researchers manipulate or cause changes in the independent variable and observe or measure any impact of those changes in the dependent variable. The independent variable is the one under the experimenter's control, or the variable that is intentionally altered between groups. In the case of Dunn's experiment, the independent variable was whether participants spent money on themselves or on others. The dependent variable is the variable that is not manipulated at all, or the one where the effect happens. One way to remember this is that the dependent variable depends on what happens to the independent variable. In our example, the participant's happiness, the dependent variable in this experiment, depends on how the participants spend their money, the independent variable. Thus, any observed changes or group differences in happiness can be attributed to whom the money was spent on. What Dunn and her colleagues found was that after all the spending had been done, the people who had spent the money on others were happier than those who had spent the money on themselves. In other words, spending on others causes us to be happier than spending on ourselves. Do you find this surprising? But wait, doesn't happiness depend on a lot of different factors? For instance, a person's upbringing or life circumstances. What if some people had happy childhoods and that's why they're happier? Or what if some people dropped their toast that morning and it fell jam side down and ruined their whole day? It is correct to recognize that these factors and many more can easily affect a person's level of happiness. So, how can we accurately conclude that spending money on others causes happiness, as in Dunn's case? The most important thing about experiments is random assignment. Our participants don't get to pick which condition they are in. Participants didn't choose whether they were supposed to spend the money on themselves versus the other. The experimenter assigns them to a particular condition based on the flip of a coin, or the roll of a dice, or any other random method. Why do researchers do this? With Dunn's study, there is the obvious reason. You can imagine which condition most people would choose to be in, given the choice. But another equally important reason is that random assignment makes it so the groups, on average, are similar on all characteristics except what the experimenter manipulates. By randomly assigning people to conditions, self-spending versus other spending, some people with happy childhoods should end up in each condition. Likewise, some people who had dropped their toast that morning or experienced some other disappointment should end up in each condition. As a result, the distribution of all these factors will generally be consistent across the two groups. And this means, on average, the two groups will be relatively equivalent on all these factors. Random assignment is critical to experimentation because if the only difference between the two groups is the independent variable, we can infer that the independent variable is the cause of any observable difference, for example, in the amount of happiness they feel at the end of the day. Here's another example of the importance of random assignment. Let's say your class is going to form two basketball teams and you get to be the captain of one team. The class is to be divided evenly between two teams. If you get to pick the players for your team first, whom will you pick? You'll probably pick the tallest member of the class or the most athletic. You probably won't pick the short, uncoordinated people unless there are no other options. As a result, your team will be taller and more athletic than the other team. But what if we want the teams to be fair? How can we do this when we have people of varying height and ability? All we have to do is randomly assign players to the two teams. Most likely, some tall and some short people will end up on your team, and some tall and some short people will end up on the other team. The average height of the teams will be approximately the same. That is the power of random assignment. Other considerations. In addition to using random assignment, you should avoid introducing confounds into your experiments. Confounds are things that could undermine your ability to draw causal inferences. For example, if you wanted to test if a new happy pill will make people happier, you could randomly assign participants to take the happy pill or not, the independent variable, and compare these two groups of their self-reported happiness, the dependent variable. However, if some participants know they are getting the happy pill, they might develop expectations that influence their self-reported happiness. This is sometimes known as the placebo effect. Sometimes a person just knowing that he or she is receiving special treatment or something new is enough to actually cause changes in behavior or perception. In other words, even if the participants in the happy pill condition were to report being happier, we wouldn't know if the pill was actually making them happier or if it was the placebo effect. An example of a confound. A related idea is participant demand. This occurs when participants try to behave in a way they think the experimenter wants them to behave. Placebo effects and participant demand often occur unintentionally. Even experimenter expectations can influence the outcome of a study. For example, if the experimenter knows who took the happy pill and who did not, and the dependent variable is the experimenter's observations of people's happiness, then the experimenter might perceive improvements in the happy pill group that are not really there. One way to prevent these confounds from affecting the results of a study is to use a double-blind procedure. In a double-blind procedure, neither the participant nor the experimenter knows which condition the participant is in. For example, when participants are given the happy pill or the fake pill, they don't know which one they are receiving. This way, the participant shouldn't experience the placebo effect and will be able to behave as the researcher expects. Participant demand. Likewise, the researcher doesn't know which pill each participant is taking, at least in the beginning. Later, the researcher will get the results for data analysis purposes, which mean the researcher's expectations can't influence his or her observations. Therefore, because both parties are blind to the condition, neither will be able to behave in a way that introduces a confound. At the end of the day, the only difference between groups will be which pills the participants received, allowing the researcher to determine if the happy pill actually caused people to be happier. Correlation designs. When scientists passively observe and measure phenomena, it is called correlational research. Here, we do not intervene and change behavior as we do in experiments. In correlational research, we identify patterns of relationships, but we usually cannot infer what causes what. Importantly, with correlational research, you can examine only two variables at a time, no more and no less. So, what if you wanted to test whether spending on others is related to happiness, but you don't have $20 to give each participant? You could use a correlational design, which is exactly what Professor Dunn did, too. She asked people how much of their income they spent on others or donated to charity, and later she asked them how happy they were. Do you think these two variables were related? Yes, they were. The more money people reported spending on others, the happier they were. More details about the correlation. To find out how well two variables correspond, we can plot the relation between the two scores on what is known as a scatter plot. In the scatter plot, each dot represents a data point. In this case, it's individuals, but it could be some other unit. Importantly, each dot provides us with two pieces of information. In this case, information about how good the person rated the past months. And that's, we have a chart here on the x-axis, and how happy the person felt in the past month, the y-axis. Which variable is plotted on which axis does not matter. The association between two variables can be summarized statistically using the correlation coefficient, abbreviated as R. A correlation coefficient provides information about the direction and strength of the association between two variables. For example, above the direction of the association is positive. This means that people who perceived the past month as being good reported feeling more happy, whereas people who perceived the month as being bad reported feeling less happy. With a positive correlation, the two variables go up or down together. In a scatter plot, the dots form a pattern that extends from the bottom left to the upper right. The R value for a positive correlation is indicated by a positive number, although the positive sign is usually omitted. Here, the R value is 0.81. So that's the result based on this plot. If you're listening to this versus watching it on YouTube, the scatter plot of the association between happiness and ratings of the past month, a positive correlation of R equals 0.81. Each dot represented an individual. A negative correlation is one in which two variables move in opposite directions. That is, as one variable goes up, the other goes down. Figure 2 shows the association between the average height of males in a country, y-axis, and the pathogen prevalence or commonness of disease, x-axis, of that country. In this scatter plot, each dot represents a country. Notice how the dots extend from the top left to the bottom right. What does this mean in real-world terms? It means that people are shorter in parts of the world where there is more disease. The R value for a negative correlation is indicated by a negative number. That is, it has a minus sign in front of it. Here, it is minus 0.83. The strength of a correlation has to do with how well the two variables align. Recall that in Professor Dunn's correlation study, spending on others positively correlated with happiness. The more money people reported spending on others, the happier they reported to be. At this point, you may be thinking to yourself, I know a very generous person who gave away a lot of money to other people, but is miserable. Or maybe you know a very stingy person who is happy as can be. Yes, there might be exceptions. If an association has many exceptions, it is considered a weak correlation. If an association has few or no exception, it is considered a strong correlation. A strong correlation is one in which two variables always, or almost always, go together. In the example of happiness and how good the month has been, the association is strong. The stronger the correlation is, the tighter the dots in the scatter plot will be arranged along a sloped line. The R value of a strong correlation will have a high absolute value. In other words, you disregard whether there is a negative sign in front of the R value and just consider the size of the numerical value itself. If the absolute value is large, it is a strong correlation. A weak correlation is one in which two variables correspond some of the time, but not most of the time. Figure 3 shows the relation between valuing happiness and grade point average. People who valued happiness more tended to earn slightly lower grades, but there were a lot of exceptions to this. The R value for a weak correlation will have a low absolute value. If two variables are so weakly related as to be unrelated, we can say they're uncorrelated, and the R value will be 0 or very close to 0. In the previous example, is the correlation between height and pathogen prevalence strong? Compared to figure 3, the dots in figure 2 are tighter and less dispersed. The absolute value of negative 0.83 is large. Therefore, it is a strong negative correlation. Can you guess the strength and direction of the correlation between age and year of birth? If you said this is a strong negative correlation, you are correct. Older people always have lower years of birth than younger people, for example, 1950 versus 1995. But at the same time, the older people will have a higher age, example, 65 versus 20. In fact, this is a perfect correlation because there are no exceptions to this pattern. I challenge you to find a 10-year-old born before 2003. You can't. Well, at the time of this writing, you couldn't anyways. Problems with correlation. If generosity and happiness are positively correlated, should we conclude that being generous causes happiness? Similarly, if height and pathogen prevalence are negatively correlated, should we conclude that disease causes shortness? From a correlation alone, we can't be certain. For example, in the first case, it may be that happiness causes generosity, or that generosity causes happiness. Or a third variable might cause both happiness and generosity, creating the illusion of a direct link between the two. For example, Wealth could be a third variable that causes both greater happiness and greater generosity. This is why correlation does not mean causation, an often repeated phrase among psychologists. Qualitative designs. Just as correlation research allows us to study topics we can't experimentally manipulate, for example, whether you have a large or small income, there are other types of research design that will allow us to investigate these harder to study topics. Qualitative designs, including participant observation, case studies, and narrative analysis, are examples of such methodologies. Although something as simple as observation may seem like it would be a part of all research methods, participant observation is a distinct methodology that involves the researcher embedding him or herself into a group in order to study its dynamics. For example, scientists back in 1956 were very interested in the psychology of a particular cult. However, this cult was very secretive and wouldn't grant interviews to outside members. So, in order to study these people, Festner, one of the scientists, and his colleagues pretended to be cult members, allowing them access to the behavior and psychology of the cult. Despite this example, it should be noted that people being observed in a participant observation study usually know that the researcher is there to study them. Another qualitative method for research in the case study, which involves an intensive examination of specific individuals or specific contexts. Sigmund Freud, the father of psychoanalysis, was famous for using this type of methodology. However, more current examples of case studies usually involve brain injuries. For instance, imagine that researchers want to know how a very specific brain injury affects people's experience of happiness. Obviously, the researchers can't conduct experimental research that involves inflicting this type of injury on people. At the same time, there are too few people who have this type of injury to conduct correlational research. In such an instance, the researcher may examine only one person with this brain injury, but in doing so, the researcher will put the participant through a very extensive round of tests. Hopefully, what is learned from this one person can be applied to others. However, even with thorough tests, there's a chance that something unique about this individual, other than the brain injury, will affect his or her happiness. But with such a limited number of possible participants, a case study is really the only type of methodology suitable for researching this brain injury. The final qualitative method to be discussed in this section is narrative analysis. Narrative analysis centers around the study of stories and personal accounts of people, groups, or cultures. In this methodology, rather than engaging with participants directly or quantifying their responses or behaviors, researchers will analyze the themes, structure, and dialogue of each person's narrative. That is, a researcher will examine people's personal testimonies in order to learn more about the psychology of those individuals or groups. These stories may be written, audio recorded, or video recorded and allow the researcher not only to study what the participant says, but how he or she says it. Every person has a unique perspective on the world, and studying the way he or she conveys a story can provide insight into that perspective. Quasi-experimental designs. What if you want to study the effects of marriage on a variable? For example, does marriage make people happier? Can you randomly assign some people to get married and others to remain single? Of course not. So how can you study these important variables? You can use a quasi-experimental design. A quasi-experimental design is similar to experimental research, except that random assignments to conditions is not used. Instead, we rely on existing group memberships, for example, married versus single. We treat these as independent variables, even though we don't assign people to the conditions and don't manipulate the variables. As a result, with quasi-experimental designs, causal inference is more difficult. For example, married people might differ on a variety of characteristics from unmarried people. If we find that married participants are happier than single participants, it will be hard to say that marriage causes happiness, because the people who got married might have already been happier than the people who have remained single. Because experimental and quasi-experimental design can seem pretty similar, let's take another example to distinguish them. Imagine you want to know who is a better professor, Dr. Smith or Dr. Kahn. To judge their ability, you're going to look at their students' final grades. Here, the independent variable is the professor, and the dependent variable is the student's grades. In an experimental design, you would randomly assign students to one of the two professors and then compare students' final grades. However, in real life, researchers can't randomly force students to take one professor over the other. Instead, the researchers would just have to use the pre-existing classes and study them as is, quasi-experimental design. Again, the key difference is random assignment to the conditions of the independent variable. Although the quasi-experimental design, where the students choose which professor they want, may seem random, it's most likely not. For example, maybe students heard Dr. Smith sets low expectations, so slackers prefer this class, whereas Dr. Kahn sets high expectations, so smarter students prefer that one. This now introduces a confounding variable, student intelligence, that will almost certainly have an effect on students' final grades, regardless of how skilled the professor is. So even though a quasi-experimental design is similar to an experimental design, i.e., it has a manipulated independent variable, because there's no random assignment, you can't reasonably draw the same conclusions that you would with an experimental design. Next is longitudinal studies. Another powerful research design is the longitudinal study. Longitudinal studies track the same people over time. Some longitudinal studies last a few weeks, some a few months, some a year or more. Some studies that have contributed a lot to psychology follow the same people over decades. For example, one study followed more than 20,000 Germans for 2 decades. From these longitudinal data, psychologist Rich Lucas in 2003 was able to determine that people who ended up getting married indeed start off a bit happier than their peers who never marry. Longitudinal studies like this provide valuable evidence for testing many theories in psychology, but they can be quite costly to conduct, especially if they follow many people for many years. Next is surveys. A survey is a way of gathering information using old-fashioned questionnaires or the internet. Compared to a study conducted in a psychology laboratory, surveys can reach a larger number of participants at a much lower cost. Although surveys are typically used for correlational research, this is not always the case. An experiment can be carried out using surveys as well. For example, King and Napa in 1988 presented participants with different types of stimuli on paper, either a survey completed by a happy person or a survey completed by an unhappy person. They wanted to see whether happy people were judged as more likely to get into heaven compared to unhappy people. Can you figure out the independent and dependent variables in this study? Can you guess what the results were? Happy people versus unhappy people, the independent variable, were judged as more likely to go to heaven, the dependent variable, compared to unhappy people. Likewise, correlational research can be conducted without the use of surveys. For instance, psychologists Leanne Harker and Dacher Keltner in 2001 examined the smile intensity of women's college yearbook photos. Smiling in the photos was correlated with being married 10 years later. Trade-offs in research. Even though there are serious limitations to correlational and quasi-experimental research, they are not poor cousins to experiments and longitudinal designs. In addition to selecting a method that is appropriate to the question, many practical concerns may influence the decision to use one method over another. One of these factors is simply resource availability. How much time and money do you have to invest in the research? Tip: if you're doing a senior's honors thesis, do not embark on a lengthy longitudinal study unless you are prepared to delay graduation. Often we survey people even though it would be more precise but much more difficult to track them longitudinally. Especially in the case of exploratory research, it may make sense to opt for a cheaper, faster method first. Then, if results from the initial study are promising, the researcher can follow up with more intensive method. Beyond these practical concerns, another consideration in selecting a research design is the ethics of the study. For example, in the case of brain injury or other neurological abnormalities, it would be unethical for researchers to inflict these impairments on healthy participants. Nonetheless, studying people with these injuries can provide great insight into human psychology. In addition to brain injuries, there are a number of other areas of research that could be useful in understanding the human mind, but which pose challenges to a true experimental design, such as the experience of war, long term isolation, abusive parenting, or prolonged drug use. However, none of these are conditions we could ethically, experimentally manipulate and randomly assign to people. Therefore, ethical considerations are another crucial factor in determining an appropriate research design. Research methods, why you need them. Just look at any major news outlet and you'll find research routinely being reported. Sometimes the journalist understands the research methodology, sometimes not. Often the media are quick to draw a conclusion for you. After reading this module, you should recognize that the strength of a scientific finding lies in the strength of its methodology. Therefore, in order to be a savvy consumer of research, you need to understand the pros and cons of different methods and the distinctions among them. Plus, understanding how psychologists systematically go about answering research questions will help you to solve problems in other domains, both personal and professional, not just in psychology. Chapter concludes with a video on research matters. The video is an advertisement, so the scientific details are not a threshold we would expect for this class. That said, this video shows the importance of curiosity and the drive to solve problems in research. If you are motivated to understand and solve problems, research is a tool you can use. So I will link that in the show notes. Well, that was a fascinating chapter on research design. I really enjoyed it. And if you like the show, share it with someone you know or a fellow student doing Psych-100. Maybe, put some comments down there, give us a thumbs up and a subscribe because you are on a pathway of discovery. You're on a pathway of learning, and we're in this together. We're in it to live a more inspired life.